In this video, we discuss about 4x1 multiplexer, how to design by using Verilog code. So it is about the 4x1 multiplexer. So we all know about what is multiplexer. So multiplexer is nothing but which has a multiple inputs and single output is said to be a multiplexer. It is one of the combinational circuit. So we already discussed in the previous video about 2:1 multiplexer. So here in this we discuss about 4x1 multiplexer. So the difference is in 2x1 multiplexer we use 2 inputs and we get 1 output. And you have one select line, but here in these 4x1 multiplexer, so they are the 4 inputs, so 4x1 in the name itself, so 4 is nothing but 4 number of inputs for the one combinational circuit and 1 number of output. So these are the select lines. So these are our select lines, these are our inputs. So 4x1 multiplexer, so we have 4 inputs and 1 output. So till now it's okay, and then we go to design code. So how you design means, so first in Verilog code we all know about it start with module and end with end module. So start with module and followed by module name. So it is a module name. So now we have to going to give the inputs. So here you can represent it with D3, D2 like that. So but in this code I represented it with I. So it's like I of 0, it is like I of 1. So third input is I of 2. And then I of 3. So I can write like this. So by using vector notation I write that 3 down to 0 means 4. So 3 down to 0 is nothing but 3, 2, 1, 0. So it is I. So we contain 4 inputs and then 2 select lines. So 2 select lines how you write? So 1:0 is nothing but 1, 0, 2 index. So it is our select line. So here in this diagram we represented AB, but in the code I represented it with select variable, SCL, cell variable. So what is our output? So output is our Y. Here I represented with out. So we have 4 number of inputs and 2 select lines as input and 1 output. So why I use reg means, so I already know about why you use reg means. In initial and always block we use what are the variables we are used in the always block or initial block, it must should be reg data type. So the output is going to assign in the always block, so that's why we use reg. So blankly we can remember that. So whenever there is a always block in the code, you must represent with output with reg data type. So you can remember that in test bench when we are using initial block, we must represent that outputs with reg data type. So in design code when you use always block, you must represent the output port with reg data type. So always at the rate. So at the rate, and it is our sensitivity list. So you can represent it with sensitivity list star means, so whatever the inputs. So if any small change, any one change means there are the 4 inputs and the 2 select lines, total 6. So if any change in the 6 inputs, so at least one change in one of the input also you get these inside block will be going to execute. So if there is no change, then this block is not going to execute. So there is a multiple statement, so that's why written begin and then case statements. Here we use case statements. So case, so what you are going to use in this case? So cell. So what are the variable you use here? So it should be inside this case. So cell, if cell value is equal to 0. So how is your truth table like? If cell value is equal to 0, our output will be I0. So if select value is equal to 1, so our output will be I1. If select value is equal to I2 is equal to 0, if select value is 3 is equal to I3, so output will be I3, means I of 0, I of 1, I of 2. It's like our truth table. So here you can observe, so it is you can represent it in Verilog as represented by binary. So that's why how many bits are there? 2 bits. So 2 tick B. B is nothing but binary. So how can you represent 0 in 2 bits? So 0, 0. So if select line, so if what is the value of select is 0, 0, then our output will going to assign to I of 0. So whatever the value in I of 0, so that is going to assign to the out variable. So if the select line is 0, 1, so 2 tick B 0, 1 means, so whatever the bits we can represent, so what is the size of these bits will be represented here. So 2 tick, so B is nothing but binary, it is a binary format. So 2 tick B 0, 1, so output will going to assign to I of 1. So like that you can write the different combinations. So what is our truth table like here? So you can end with this case with end case. So these begin with end and this module with end module. So for every statement begin with, you can end with some keyword. So here there is a begin keyword, you can end that begin keyword by end keyword. So case will be ended by end case. So module will end by end module. So like that we can design a code for the 4x1 multiplexer. So it's our test bench code. So how it looks like means, So module, it is also start with module and end with end module. So and then marks, it is our module name. You can take any name, so it should be like related to module. It is related to circuit, means then it is easy to identify which type of code it is, or after long time also you can remember that okay, it's like 4x1 4x2 multiplexer code, like that. So inputs are represented in reg data type, so outputs are represented in byte data type. So what are the here you can observe what are the variables we are used in the variables used in this inside the initial block. It must should be reg data type. So not in initial block are always block. So what are the variables we are going to assign the values? So that should be reg data type. So that's why here you can use reg. So out is not used in this initial block. So that's why you can represent it by wire. So then we can write this instantiation here. So by using this only, this test bench code is going to connect with this design code. So how you connect this test bench and design code? By using this line. So this line is very important, so we can should connect these two codes by using this line only. So it is our module design code module name, so it is our instance name. So you can use any instance name. So mostly we can use DUT design under test. So it's not particularly about DUT, you can use any name. That's why I specify like this. So you can use any name. So you can connect the port. It is our port connection. So port connection video is already done. If you don't watch it, so then go and watch. It is very important to connect this port connection. So port connection is by order. So there is a port connection of name also. Here I use port connection by order. So then initial block we give different combinations of input and give some delay, like that. So then end begin with these begin is stop by end. So these are our print statements. Like printing means if you want to display anything in our console window, so we are going to use this monitor statement or display statements, like that. So here I use monitor. So why I use, so here I display time and the select line and input and output. So it should be in binary format. That's why I use %b like that. So these are the values we are going to assign, like that. So these begin will stop with end. So these lines are going to use for the waveform generation. So I code this program in EDA playground. So that's why for generating waveform I use these 4 lines. So and stop with end module. So it is our test bench code. In every video I discuss about test bench code. So the format of the test bench code is similar to every program. So the what are the inputs and take the combinations of the inputs. So that is the main difference to every test bench code. So that's why I don't waste much time about on test bench code. If you have any doubts in the particular test bench code, then you can message me and I create a separate video on the complete test bench code for every single line. Till now I am just say that there is a different combinations, like that. So if you have any difficulty to understand these input combinations like this, so then you can comment it, so I can detailedly explain that. So maybe every video I discuss about test bench code, so that's why I don't go detail about this test bench code. So initially I go through every line and every step in detail, but now it's very familiar because when you are going to do number of programs, so it is very same format. So the combinations of the input will be different. So it is according to our test bench, and then whether you are doing correct or wrong. So it is a functionality. You can take as you like. So not about following something. So you can take any combinations and check whether your combination is correct or according to your function or what you are going to design, like that. So this is our output waveforms, like that. So here we can observe. So I can select the line here, so that these values are going to assign here. So you can see select line. So select line is equal to, so in 0 index 1 index. So it is our indexes. So what is the value? 0 1. So select of 1 value is equal to 0, select of 0 is equal to 1. So it is our value, it means 1. So select line is equal to 1 means, so what is our output? So select line is equal to 1 means our output will be I1. So whatever the value in I1, so that is assigned to be out variable. So here you can see what is the value of I of 1. So it is 1. So this 1 is going to assign to the out. So here you can observe the out value is equal to 1. So I of 1 is equal to 1. So but better understanding, I take remaining all values as 0 and only I of 1 will go into 1. So that's why you can easily understand whether your program is correct or wrong. So you can take any combination. So cross check what is the select line. So what is the value you are going to assign to your output variable. So you can cross check those values. So you can simply say whether your code is correct or not. So here my select line value is equal to 1. So I1 value is going to assign to the output variable. So it is going to assign. So my program is correct. So you can cross check like that. So if you have any doubts, you can comment it. Until now it is our 4x1 multiplexer. So thanks for watching. Okay, bye.